In today's tutorial, we will start a new series called Solving Exam Riddles. This is part 1. And here we have a task from a recent test. We have this diol with 2 cyclobutane moieties. And the question is, how can we transform this molecule into this structure to unrelated 5-membered rings? And the questions are, which reagents do we need? And what are the intermediates that are involved, both reactive and isolable intermediates? So, a complete mechanistic scheme should be developed. Please try to solve this riddle first by yourself before listening to my explanation. Okay, a 1,2-diol is called pinacol. We need some kind of rearrangement. A pinacol-pinacolone rearrangement is certainly a good idea to start with. What do we need for that? Acid catalysis. So, in equilibrium, we will protonate one of the 2 hydroxyl group. We will eliminate water and will obtain as a reactive intermediate this carbocation. This now offers the opportunity of a rearrangement that, for instance, this carbon atom with this bonding electron pair is migrating, being transformed from a 4-membered to a 5-membered ring, releasing ring strain and leading to this spiral cyclic system, here mesomerically stabilized, with this cation, carbocation, as one mesomeric structure. Don't forget, the truth lies in between, but more close here at this structure, since the carbon is less electrophilic compared to the oxygen. Finishing the pinacol-pinacolone rearrangement would mean, we just deprotonate and will have this ketone. On the other hand, we should, of course, have the idea that also here a second rearrangement step could take place to this cation. So, rearrangement, Wagner-Meerwein type rearrangement, already forming the annihilated 2 5-membered rings with the carbocation here. It seems to be that we are already pretty close to that structure, thus just eliminating the OH group. Well, but there is a problem. If we eliminate a hydroxide and ion, then what would result? Something with two cationic charges, just impossible. And also we cannot eliminate an OH plus, since oxygen is highly electrophilic. Well, to get rid of a charge, we could eliminate one proton, deprotonate, having a double bond here or there, but this does not help for reaching the structure. Well, another stabilization could occur, forming an epoxide. So, what we indeed need getting to this structure is having an alcohol like that, and with acidic catalysis eliminating water, we would end up with our target molecule. So, and from here to there, no problem. Just a reduction step. We have to choose reagents. What could we use for that? Catalytic hydrogenation, one possibility. A complex hydride like lithium aluminum hydride. And well, the task is finished. However, we can't be sure that indeed that epoxide is an intermediate that we can isolate. Maybe this is the only one which we can isolate, but in that case, again, reduction. In this case, sodium borohydride is sufficient for reducing the ketone. And now, first, protonating the OH group, forming the water-leaving group, then rearrangement, Wagner-Meerwein rearrangement, giving this structure, and then just deprotonating will lead us to the target molecule. Thanks for listening.